everyone, it's me 𝗂𝗂 from How to Electronics. Today, I am going to show you how I designed an ESP32 based fingerprint biometric voting machine with a professional web dashboard. This system can register voters, scan fingerprints, record votes, and display all results in real time. For this project, I used an ESP32 development board as the main controller, an R503 fingerprint sensor for biometric verification, and a 0.96-inch OLED display to show system messages, fingerprint status, voter name, vote status, candidate selection, and registration progress. The ESP32 connects to a Wi-Fi network and hosts a beautifully designed local web dashboard. The dashboard has multiple sections, such as Dashboard, Enroll Voter, Live Results, and Voter Management. The main dashboard shows live fingerprint activity, system status, latest events, and vote feed in a clean and professional layout. You can export the vote data as well and later view it in Excel or Google Sheets. For now, let's find out how we can build this ESP32 fingerprint biometric voting machine. Let's get started. The PCB used in this project is sponsored by Avon, a global leader in PCB manufacturing and assembly. Avon provides high-quality PCBs with fast production and delivery times. For new users, there is currently a special campaign that includes free shipping and generous discounts, making PCB prototyping far more affordable. You can get a PCB at $1 and PCBA service as low as $35 only, and with free shipping. Welcome back again. Let's take a look at the components required to build this project. First, we need an ESP32 microcontroller board. Then, a fingerprint sensor. I am using an R503 capacitive fingerprint sensor. A 0.96-inch OLED display, 4 push buttons, some capacitors of 10 microfarads and 100 nanofarads. You can buy all of these components easily from anywhere. Let's have a technical overview of the R503 fingerprint sensor. The R503 is an integrated biometric fingerprint module that contains an optical/capacitive sensing area, a built-in DSP processor, flash memory, and a UART communication interface. It does not send the raw fingerprint image to the ESP32 for matching. Instead, the sensor captures the fingerprint, extracts unique feature points, creates a fingerprint template, and stores this template inside its internal memory. The R503 communicates with the ESP32 using UART serial communication. Here is the circuit diagram for this project. The ESP32 is the main controller of the system. It reads fingerprint data from the R503 fingerprint sensor through UART communication. The OLED display is connected to the ESP32 through I2C and is used to show messages. 4 push buttons are connected to the ESP32 for candidate voting after fingerprint scan. Voter enrollment is done only from the web dashboard. Capacitors are added near the power supply lines to improve stability and reduce noise during operation. After designing the schematic, I converted it into a compact PCB layout. All the components are placed on the front side for easier assembly. The routing is done based on signal requirements and component placement. Here is the 2D view of the board from the front side and also from the back side. Similarly, here is the 3D view of the board. The 3D view looks awesome, so the next step is to order the PCB. The Gerber files were generated and uploaded to Avon. Uploading the Gerber file is simple. Just select the board parameters like material, thickness, solder mask color, and quantity. And here, you can see the total quote of just $1. And shipping is also free. If you want to order a PCB for just $1, click the first link in the description. I placed the order, and within a few days, I received these high-quality PCBs. The finish, silkscreen, and through-hole plating were excellent. Next, I soldered all of the components for 15 minutes. The assembly was smooth, and the board looks professional once completed. For ESP32 and OLED display, I'm using a female header. I could insert all of the components easily here. For For the 𝗓503 fingerprint sensor, I used wires as this sensor needed to be placed in a particular position. Now, let's move on to the coding part. We will develop a C++ code to interface the 𝗓503 fingerprint sensor and OLED display with ESP32 and visualize the fingerprint voting on a web page. The code starts by including the required libraries for the project. The Adafruit fingerprint sensor is used for 𝗓503 communication with the ESP32. The Adafruit GFX and Adafruit SSD1306 libraries are used to control the OLED display. In the Wi-Fi section, the SSID and password are added so the ESP32 can connect to the local network. The main loop continuously checks fingerprint scans and candidate button presses. These events are displayed on the OLED screen, printed on the serial monitor, and sent to the web dashboard as JSON data through the API routes. Here is the header file for the project. The dashboard.h file contains all the HTML, CSS, and JavaScript code used to create the live web view. Once the hardware assembly is complete, it's time to upload the code. To upload the code, connect the Type-C USB cable directly to the ESP32. In the Arduino IDE, go to Tools, Board, and select ESP32 Dev Module. Then, choose the correct COM port. Finally, click the Upload button. The code will then be uploaded to the ESP32 board. After uploading the code to the ESP32, the device starts initializing all of the connected modules. Once the ESP32 connects to the local Wi-Fi network, it displays the IP address on the OLED screen. Finally, the system enters scan mode. To access the web dashboard, enter the IP address on a web browser. The dashboard page shows the live fingerprint system status, Wi-Fi connection, latest API update time, and live vote activity feed. From the left side menu, we can open different sections such as Dashboard, Enroll Voter, Live Results, and Voter Management. The Enroll Voter page is used to add voter details and start fingerprint enrollment. The Live Results page shows vote counts and vote history, while the Voter Management page displays registered voters and their voting status. The dashboard also includes options to enable sound alerts and export vote data as a CSV file. To register a new voter, open the ESP32 web dashboard and go to the Enroll Voter section. Here, enter the voter details such as name, ID number, DOB, sex, and city, then click the Start Registration button. After starting the registration, the dashboard shows an Enrollment Started pop-up, and the OLED display asks the user to place a finger on the 𝗓503 fingerprint sensor. The sensor first captures the fingerprint image, then asks the user to remove the finger and place the same finger again for the second scan. Once both scans are matched successfully, the fingerprint template is saved in the 𝗓503 sensor memory, and the voter details are stored in the ESP32. The OLED display shows a success message, and the dashboard also displays a registration successful pop-up with the voter name, fingerprint ID, ID number, and city. After registration, a registered voter can scan their finger, press a candidate button, and cast one vote during the election. When the voter selects a candidate, the dashboard displays a vote success pop-up with the voter name, fingerprint ID, ID number, and selected candidate. If the same voter scans again after already voting, the system blocks duplicate voting and displays an already voted message on the dashboard. The dashboard also keeps updating the live vote feed, live results, and voter records. In the live results section, vote counts and vote history are shown with name, ID number, finger ID, candidate, and message. The voter management section shows all registered voters along with their assigned fingerprint IDs and a delete option. The dashboard also provides an Export Votes CSV option. This allows the vote history to be downloaded as a CSV file, which can be opened in Excel or Google Sheets for record keeping. That's all from the video part today. I hope you liked this video, so why not drop a like and hit the subscribe button? Finally, thank you so much for watching. See you in the next video.